So today we're going to look at the angle sums of different types of polygons. We know, for instance, that a triangle is going to add to 180. So if we just do a quick recap here, if I draw any triangle, this top angle plus this angle plus this angle right here, if you add all those together, you'll get a measure of 180. It doesn't matter whether the triangle is big or small, could be obtuse, could be acute, could be right, could be top to bottom, could be bottom to top, doesn't matter how it's oriented. Any triangle is always going to add up to 180 when you add up all the individual angles together. Now, if we know that, we can actually apply that to figure out the angle sums of other types of shapes, quadrilaterals, pentagons, all that stuff. So keeping that in mind, let's look at a quadrilateral. So this right here looks like a square, but we can't assume it's a square, even though it looks very much similar to one. We'll say this is any four-sided object. And I want to know if I take all the angles. So if I take this angle, plus this angle, plus this angle, plus this angle. If I add up all four of those angles, what number will I get? Okay. For any quadrilateral, what number would I get? Well, the way we figure that out is we basically see how many triangles can I cut this four-sided object into. Now, there's a few rules on how you cut the triangle, though. The first rule is you have to cut in a straight line corner to corner. So, for example, I can't do this because that's not from corner to corner. That's corner to side. And I can't do this because that's not a straight line corner to corner. It goes straight and then it turns and goes to the next corner. So it has to be a straight cut from one corner to the other as the first rule. And the second rule is I can't cross a cut I've already made. So for instance, if I make this cut here, I could not make that dotted cut there because I'm crossing a cut I already made, and that's not allowed. Other than those two rules, you can make any kind of cuts you want. So we want to figure out how many triangles can these shapes be cut into, because if each triangle has a sum of 180, and we can figure out how many triangles are in the shape, then we can figure out what the angles of the shape are going to be. So for this first quadrilateral, I'll just make my first cut here, corner to corner, straight line. Now if I go to try and make a second cut, I come across a problem because the only other corners that are available is the bottom left and the top right. But if I try to cut through those corners, I'll be cutting over a cut I already made, and I can't do that. So this is about as many cuts as I can make, as many triangles I can make, and I see that there are two triangles. So there's two triangles. Each triangle has 180 degrees in it. So I'm going to say 180 degrees times 2 for two triangles. And that's going to be 360 degrees. So a four-sided shape, again, this could be a square, rectangle, parallelogram, rhombus, trapezoid, doesn't matter. Any four-sided shape, you can cut two triangles out of it at most, and so all the angles in that quadrilateral should add up to 360. And again, if you don't believe me, you can draw a new quadrilateral and cut from corner to corner the same way we were doing, and you will not get more than two triangles. Okay? The maximum you can get is two triangles, so the angle sum of any four-sided shape is going to be 360. What about for a pentagon? Okay, let's start from the bottom left corner here. So I can make a cut there. That's good. I can make a cut here. Now I can start at the same corner. Starting at the same spot is fine. I just can't cross a cut. So that's a valid cut that I just did there. But that's probably my last valid cut. I can't cut anything else on the shape, otherwise I'm crossing a cut already made. So let's see how many triangles we get here. So for a pentagon, 5 sides, we have 1, 2, 3 triangles. So 180 times 3 is going to give me 540. So there's 540 degrees in that pentagon. So again, if I add up all those angles, right, if I added up this angle here, 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 I'd get 540 degrees. And again, it doesn't matter what type of pentagon it is. It could be a pentagon like this one, or you could stretch and twist the lines a little bit. As long as it has 5 sides, all the angles are going to add up to 540. The last one's a hexagon. So cut there, cut there, cut there, and that's about as many cuts as I can make. Now again, this isn't the only way you can cut these shapes. It's just one style of cutting them. But no matter what you do, you're always going to end up with the same answer. So in this case, we're always going to end up with 1, 2, 3, 4. So a 6-sided shape gives me 4 triangles. So the angle sum is 180 degrees for each triangle times 4 triangles going to be 720 degrees. Again, it's for any type of hexagon. So we can kind of start to develop a pattern here if you look closely. Four-sided shape gave me 2 triangles. Five-sided shape gave me 3 triangles. Six-sided shape gave me 4 triangles. A seven-sided shape is probably going to give me 5 triangles. An eight-sided shape will probably give me 6 triangles. And so on and so on and so on. So there's a pattern developing here that we can kind of attach to. That every time we add one more side, starting from 4, every time we add one more side, we're going to get one more triangle. So again, 7 sides would be one more triangle than the last, it'd be 5 triangles. 8 sides would be one more than that, so it'd be 6 triangles, and on down the line. And because the triangles are always going to add to 180, we can use this to make a formula. Okay? This formula is called the interior angle sum formula, or sometimes called the interior angle sum theorem. Okay? So the interior angle sum formula, or the interior angle sum theorem, goes a little something like this. Okay? We know that there's a certain number of triangles that is going to go to each shape. In this case, there's another sub-pattern here that the number of triangles you get is equal to the number of sides in the shape minus 2. So 4 minus 2 is 2. 5 minus 2 is 3. Whoops, minus 2. 6 minus 2 is 4. The next one would be 7 and 5, right? Well, 7 minus 2 is 5. The next one would be 8 and 6. Well, 8 minus 2 is 6. And on and on and on down the line. So if I gave you a 100-sided shape, you could figure out that there are 98 triangles in that 100-sided shape because it's just 100 minus 2. So the first part of this formula is just that, n minus 2. So this part right here represents the number of triangles in the shape. That n minus 2 is how many triangles you can cut that shape into. But remember, this formula should tell us what the sum of all the angles in the polygon is. That's why it's called the interior angle sum theorem. So I want a formula that will get me the angle sum of all the inside angles of any shape. This right now just tells me the number of triangles. To get the actual sum, I'm going to do my 180, which is exactly what I have written here, here, and here. To get the angle sum of any shape, you take 180 degrees times the number of triangles that the shape has. And in this case, to find the number of triangles the shape has, you take the number of sides and minus 2. So that's where we get this formula from. It's the number of sides minus 2, that's the number of triangles, times 180, because each triangle is 180, and that will give you what the angle sum of the entire shape is. So again, if I gave you a 100-sided shape and said, what do all the angles in a 100-sided shape add up to be? You would just do 100 minus 2, it's 98, and then times that by 180, and that will give you the angle sum for that shape. Okay? So again, this works for any shape of any type, as long as it's a polygonal shape. So how do we use this? Well, architectures, anything that deals with construction, can use this every now and then, because if you're designing a building, and you're designing it in sort of a hexagonal shape, or using a hexagonal structure, and you know the angles need to be a certain way, if you've made 5 of the 6 angles one way, you can then figure out by math here what degree that 6th angle will be, how big that 6th angle will be, because it's based on the other 5. So you can use this to make sure you don't space things out too small or not wide enough or too wide, so that all the angles will line up into how you need them. So anything dealing with design, art, architecture, all that can trace back to this. So how do we use this in a typical math problem? Well, a very typical problem looks something like this. You'll have a, in this case, 5-sided shape, so it is a pentagon, although it doesn't look like a normal pentagon. We do have 1, 2, 3, 4, 5 sides. And I want to figure out what that missing small angle is, that missing x angle. How do I do that? Well, I'm going to use my formula, and I'm going to use the angles I have to figure out how much I need or how much is left over. So the first thing I'm going to do in this problem is figure out what should all these add up to be. If I add up all these angles, including the x, what should it be? Well, how do we do that? We just use our formula. 180 times n minus 2. This basically gives us a target number that we have to reach. So let's go ahead and plug in our n here. So n, remember, is the number of sides. So in this case, it's 5 sides. So it'd be 180 times 5 minus 2. So it's 180 times 3. So it's 540. So that right there is our target number. That's how many degrees all the angles in that shape should add up to be. It's 540 degrees. But we don't know what one of them is. We don't know what x is. We just know of the 4 others. So what we're going to do is we're going to add up the 4 others and see how much we have right now. So plus those, plus those, plus those. We're going to add up what we have right now. So 115 plus 140 plus 130 plus 125, whoops, 125. If we add up all those, we get a nice 510. And that represents how much our angle sum is right now. But our formula says that we need 540 when all of them are put together. Right now we have 510. So how much does x need to be? Well, some of you might be able to figure it out right now, but if you don't, you simply take what you need minus what you have, and that will get you what's left. And this right there will be your missing angle part there, at 30 degrees. So that missing angle has to be 30 degrees in order to keep this a 6-sided shape. Or sorry, a 5-sided shape. If it's anything more or less than 30 degrees, the shape will not work out. Right? It will not be built as specified. So it really just boils down to figure out what you have, figure out what you need, subtract them off, and then find what's left. And whatever's left, there's your answer. Now this was a very straightforward one. No big tricks there. Some are a little bit trickier, like this next one. I wouldn't necessarily say trickier, but it does have a little bit of an extra step to it. So in this case, we have a very similar problem. We now have a 6-sided shape, okay, just to make sure. 1, 2, 3, 4, 5, 6. And as before, we are missing an angle, but the angle is given to us a little bit differently than the last one was. So first, let's do our formula. Okay, let's figure out our target number. 180 times 6 minus 2. 180. 6 minus 2 is 4. 180 times 4 is 720. So that's our target mark, is 720 degrees. How much do we have right now? What are all the sums are the angles that we know? So 1, 2, 3, 4. We're going to add up all those angles. So where I'm down here, 170 plus 100 plus 92 plus 93 plus 95. And we're going to figure out what's that sum right now. Well, that sum right now is 550. 550 degrees. Now, what we could do is take 720 minus 550, and that'll give us what's left. But if you notice here, this angle, this x plus 50, that's that entire angle. So if I did 720 minus 550, that will give me how big the angle needs to be, but would not give me the variable, would not give me x. If I did this, 720 minus 550, that will tell me a total of 170. Again, if you don't believe me, go ahead and do the subtraction there. But this 170 is the entire angle here. Okay? That's that entire arc. I just want what x is. I don't want the entire arc. I just want what x is. So I have to do another little quick equation here. If the entire arc is 170, and that's what x plus 50 is, then to get x, I'm just going to subtract off that extra 50, because I don't want that 50 in that 170, and 120 would be what my missing variable is. So my missing variable is going to be 120 degrees, is what x stands for. So in this case, you have to be very careful about what they ask. If they ask you for the entire angle, then just get them the entire angle, like we did in the first problem. If they ask you for a specific variable value, then you have to make sure you're careful and see if you have to get rid of any other addition or subtraction bits there. Now we could have done this a little bit differently. For example, I could have taken that 50 and put it in with this addition here. That way I wouldn't have to subtract it off later. That's one thing you could do. You could set up as one big giant equation with all the angles in there. But this is another way of doing it as well. Just figure out what you have, subtract it off, and then subtract off any extra bits you still need to get rid of. Now this all deals with outside angles. Or sorry, these all deal with inside angles. Can't spot today, evidently. These all deal with inside angles. So every angle here is inside, 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 inside. So all these angles are inside. Same thing with the other one. All these angles are inside, 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 inside. What about the outside angles? Because they have some special properties of their own as well. So by outside angles, what I mean, if I go over here, is the angles that I have in sort of color here. So the outside angle is like this angle right here, this angle right here, 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 and here. Those angles are what we call exterior angles because they lie outside the shape. We normally don't see them because usually when you're drawing a shape, you don't draw the extra line there. You just draw the shape and cut it off where you need to. So they're normally not shown, but they do have a special property because they too have a common sum. And that is, if you take all those outside angles and you add them together, you get a nice round 360 degrees. How do you know? Well, there's a visual way we can do this. If I take each of these pieces and I try to put them together, I have to do this very carefully here or else I'm going to butcher the picture. So if I take each of these pieces and put them together, they should, give or take human error here, form a pretty decent circle. If I fit the last one in there, so you can see all these angles are going to form a full circle. So that means they're all going to add up to 360. So all those angles that were on the outside, if you put them together, if you just kind of copy them, rip them off the polygon, and put them all together, they'd be put together in the form of a nice full circle. So we know that they're going to add to 360. And this is true for any polygon. So it's not just for a certain amount of sides. Any polygonal shape, any convex polygon, which means that the corners are pointing outwards, any convex polygon will have this property here, where all the outside angles are going to add to 360. Now, a polygon is not convex, just so you have some extra information here. This polygon right here, that's a convex polygon. Its corners are pointing outwards. A concave polygon is a polygon where it kind of collapses in on itself at one or more points. So, for example, this would be a concave polygon because it caves in on itself right around here. The corner actually points into the shape rather than outside the shape. But for convex polygons, all those outside angles are going to form a nice 360 degrees. So you can solve for missing angles on the outside just as well as on the inside now as well. You just have a different target number. In fact, it's an easier one because you don't have to use a formula for it. So if I want to figure out what x is, I'm just going to simply add up what I have. 70, 90, 74, whoops, missed one, 54. 70, 90, 74, 54, if I add all those together, I get 289. That's how much I have. Remember, since it's the outside angles, I need 360 degrees. So I'm going to put 360 minus 289, and I get x is 71. Okay, that's how much x needs to be in order to get me a nice 360 circle. So those are the angle properties for both interior and exterior angles of different types of polygons. Again, the interior angle ones depend on how many sides you have. You have to use that 180 trick. For the exterior angles, though, it doesn't matter what size the polygon is or how many sides it has. It's just always going to be 360. So, hope you enjoyed the video. Have a good day.